Hello everyone, welcome to KGS. Today in this session we are going to discuss about a current affairs topic, and the topic is cloud seeding. I hope you must be aware of the context of this topic. The context is that in Delhi we have experimented this particular program in order to reduce pollution caused by let's say particulate matters especially. Now how cloud seeding would be related to or is related to the pollution control. Now, cloud seeding is a process, and its result is artificial rain. As raindrops will fall, they would also be ensuring that they water saturate the particulate matters, and then those particulate matters will be able to settle down on ground. And that's why we can use cloud seeding as one of the methods, one of the processes to handle pollution. But in Delhi, the experiment that was carried out by Delhi government in association with IIT Kanpur could not yield much, because the rainfall that occurred was too sporadic, and there was no way to ascertain whether the cloud seeding experiment led to that particular rain. Fine. So that is the context of the topic that we will be discussing. But here what you need to be aware of is what exactly is cloud seeding. So let us try to understand what is cloud seeding. Cloud seeding, as per the definition given by Indian Institute for Tropical Meteorology, is a weather modification technique. It is a weather modification technique because naturally there might not be the case that rainfall would occur, but we are intervening to modify weather, and we may have rainfall after that intervention. Now how do we intervene? We intervene based upon the cloud condensation nuclei, CCN, cloud condensation nuclei. We spray cloud condensation nuclei with the help of aircrafts in those clouds which consist of moisture. Now, as we use these cloud condensation nuclei, there would be condensation of water vapor that would occur, leading to formation of water, and that water will coagulate. It will form group, and over the period of time, it would let's say fall on ground in the form of rainfall. So that is how we carry out cloud seeding experiment, and this cloud seeding experiment is basically of two types, right? Basically it is of two types. First is hygroscopic seeding. Hygroscopic particles are used, and those particles are kind of water absorbing particles. As they absorb water, there would be, let's say, a group of water droplet that would be formed, and then that water droplet will be able to fall in the form of rainfall. So in hygroscopic seeding, we use particles which will be able to coagulate water. Now, in order to carry out hygroscopic seeding, we target warmer clouds. Warmer clouds does not mean 10 degree, 20 degree Celsius cloud. Those clouds whose temperature is more than freezing point would be targeted under the hygroscopic seeding. Now, apart from hygroscopic seeding, we have one more type which is more important, and that is glaciogenic seeding. In glaciogenic seeding, what we do, we target those clouds which have relatively colder temperature, right? Temperature would be let's say below freezing temperature, and that's why we can say that those are relatively colder clouds. Here we use those particles which will be able to act as nuclei for the coagulation of ice particles. Now, as those ice particles coagulate, they would come down in the form of let's say rainfall. Why? Because as they pass through the atmosphere, they would be heated up, and that ice would be converted into rainfall. So these are two major types of cloud seeding experiments that we have. First is hygroscopic seeding, and second is glaciogenic seeding. Apart from that, one more type is there, and that is dynamic seeding. In dynamic seeding, we make sure that there would be, let's say, vertical flow of air, and as air, let's say, flows vertically, there would be condensation process that would occur, which may again lead to rainfall, right? So these three different techniques are there of cloud seeding. Fine. Now, if we talk about the background of cloud seeding experiment, it was invented in 1940s, but in India, it was used in 1952 in Kolkata. IMD used cloud seeding experiment to carry out to get rainfall. But again, there is hardly any method that would help us identify whether the rainfall has occurred because of cloud seeding or something else, or is it a natural rainfall or artificial rainfall. That we won't be able to ascertain, right? And if we talk about the recent experiments, significant experiments of cloud seeding, in 2008 during Olympic, China used this kind of seeding experiment to make sure that the clouds before some important events, like let's say opening event or closing event, they can clear those clouds. So that's what is cloud seeding. Now let us try to understand why it does not work always. Why it does not work always? See, there are some prerequisite for the cloud seeding experiment. First, that cloud should have moisture content. If clouds does not have moisture content, then there would be no rainfall, right? So wrong cloud type. If you select wrong cloud type, that means which does not have rainfall, then there would be problems. Secondly, if no clouds are there, we won't be able to carry out cloud seeding experiment, right? Thirdly, there might be unpredictable weather. Unpredictable weather means, let's say you have spread these cloud condensation nuclei like silver iodide, dry ice, or even salt particles like NaCl. When you use these particles, you have put them in a particular cloud, and if there is lots of, let's say, wind, then those particles would be dispersed in the air, and hence that experiment might not be of any use. So that is also one of the problems. And then tiny scale, that means these experiments would give you let's say rainfall in a small area, and there are hardly any methods to ascertain that this rainfall has occurred due to cloud seeding only. So those are the problems. That's why cloud seeding does not work always. Now there are some the context that was related to Delhi cloud seeding experiment. So this experiment was carried out by Delhi government in association with IIT Kanpur, and they used an aircraft, that is Cessna 206H aircraft, and this aircraft was used, and they spent almost 60 lakh rupees for this particular experiment, but again not much result, right? No rainfall was triggered, but the claims were that some drizzle was there in Delhi NCR region. Fine. Now let us try to understand what are the limitations of cloud seeding experiment. The most important limitation is that you won't be able to carry out cloud seeding in any season, right? It is a seasonal method. When you have moisture laden winds, when you have moisture let's say in the air, then only you will be able to carry out cloud seeding. Why? Because you are just providing some nuclear for the condensation of water, right? And that's why you need to have water vapor, then only you will be able to carry out cloud seeding experiment. So it is a seasonal thing. Secondly, cost benefit consequences. We don't know exactly whether the experiment would lead to rainfall or not. And if we take into account the cost factor, the cost of these kind of experiments is huge, because we need lots of let's say support from you need aircraft, then pilots, technical personnel, and those salt mixture that we want to put in the clouds. All those incur lots of cost, and that's why cost benefit ratio is also not much as far as cloud seeding experiments are concerned. That is second. Thirdly, environmental concerns. Now see, in order to take care of air pollution, we want to carry out cloud seeding experiment, and to carry out cloud seeding experiments, we are putting some nuclei, cloud condensation nuclei in the air. They may be silver iodide, they may be dry ice particles, they may be NaCl or salt particles. Now when you put these particles in air, and if it does not rain, they will remain accumulated in that particular area, and they may cause some environmental concerns. There would be health impact on people because of these kind of particles. So that is also one of the important consequence of the cloud seeding. Then the next important consequence is unknown long-term effect. We don't know how these, let's say, particles that are there in air would behave on the long-term basis, right? So that is also one of the problems. And lastly, the cloud seeding is a short-term measure. Another problem with cloud seeding is that it is a short-term measure. We cannot use cloud seeding as a long-term measure for, let's say, getting rainfall or for pollution control. Fine. So those are some problems with respect to cloud seeding. Now, what is the way forward? What is the way forward? First of all, you need to recognize that this cloud seeding can be only a supplementary measure. It cannot be your main measure to tackle pollution. Secondly, what you need to do, what you need to focus upon is pollution control. Pollution control, the sources that are leading to pollution, those we will have to control. And in addition to that, once we control them, in addition to that, we can use cloud seeding, right? So that is what we will have to do. Then there has to be regulatory framework, right? That means there is a need of proper SOPs. There are proper guidelines that we need to carry out these experiments, because there are some environmental concerns related to this. Then you can also try to understand what are the long-term impacts of this particular project, this particular process on the environment, on the let's say health of people. For that, you should collect the statistical data that is being collected by different agencies like this. That in the USA, they have warming weather modification pilot project in the US, wherein they are trying to collect some statistical data about cloud seeding. So based on that statistical data, let's say if India also collects that statistical data, we'll be able to understand the long-term impact, we'll be able to understand whether it is harmful to health or environment, right? So to conclude, we can say that cloud seeding can be one of the measures of pollution control, provided we focus more on pollution control from the sources like vehicular emission, industries, construction activities, stubble burning, etc. And then we can carry out as an additional measure cloud seeding. So that is about our discussion of this topic. Thank you.